is orange Tessie bot. It's the same as our other room. There you will see you can do everything with the schedule, and the most important part, asking questions, is done only through a chatbot. So you just type question or talk, it will list the current talk, you ask a question, and I will moderate the questions for the speaker to get the best experience out of this and to be the most efficient. And of course, when you like a talk, there is a rating, very important. Please rate talks. Speakers would appreciate it a lot. Yeah, you will find many useful information there. You can find about local food, other stuff. You can build your own schedule. If you're interested in a specific topic, just type find talks about microservices or find talks about agile. It will return just the talks. You can build your own schedule and then get notified when you need to go to that room that the topic is on. And so yeah, once more, ask questions here. So at the end, like, we'll have a couple of questions listed and ask for our speaker, and enjoy the conference. And now I will give the stage to Fred George. He will talk something about microservices. Enjoy.
Thank you. Thank you. So I've been doing microservices for actually quite a while now. I think my first project I labeled as microservice was when I was doing some work for General Motors in Detroit in 2005. Actually, it was considered a bad idea at the time, but I'm glad it's caught on a little more. But now that I've talked about microservices, I also want to talk about the trouble you get into doing microservices and to sort of warn you that it may not be correct for you to worry about this. That's just a little bit about me. The nice thing kind of over here, basically the top says I'm really old, but fortunately I'm not the oldest person. Dave Parnas has that distinction. But I typically have, though, worked into stuff that's sort of on the right-hand side. I've typically been a consumer of new technology my entire career. Getting into computer networks back when we didn't have an idea of two computers talking to each other, local area networks, graphical user interfaces, and early Agile adoption. So a lot of things I talk about may not be appropriate for you, because this is early adoption of things. But don't worry about that. Probably in the next 5 years it'll be relevant. So what do we mean by microservices? Well, there's a lot of ideas out there, but generally the beginning people in this industry sort of have these agreements. First of all, they're really small. You think you know what small is until you actually start doing them, and then you realize they're really small. The second thing we kind of agree on, if it takes more than one person to do it, it's not a microservice. I run across a lot of clients saying, oh yeah, we have this team of 16 people working on this microservice. And I'm like, yeah, I don't think so. You may be building a service, maybe an appropriate thing to do, but it's not a microservice. They're very small, easy to maintain. They're very loosely coupled, because the idea behind that is we want to be fast. And the more loosely coupled we are, the faster we can try these things out. And a lot of this stuff's all about speed. One of the things that makes us faster is I want to be able to run two versions at the same time. And you sort of say, well, that seems to be a problem. Well, yeah, it's a problem if you try to run one version and try to go to a new version. You have to change all the people using that version at the same time and making sure you didn't break something. That slows you down. And again, microservices is about how fast I can try things out. Microservices need to be self-monitoring, so if they're waking up and trying to do something that doesn't work, they need to acknowledge that. They need to sort of catch that themselves. And finally, the idea you want to do something interesting, you should publish it. Don't worry about who needs it. This is an idea we stole from Google. The idea with Google was when something interesting happened with a search, they would just publish an event about it. And the nice thing was they were able to put these events together in the future for some other reason. Find something new idea to try out. It was easy to try these ideas. But imagine if it was like, I have an idea, I need to go to you and you and you and get you to change your interface and publish something new. Well, you're going to ask, why do I need to do that? Should I do that or not? And so the idea will die. The nice thing about Google is they put these ideas out there. If you're trying to find the application of today in this sort of microservice world, it doesn't really exist. There's just too many of them. They're used in various and sundry ways. So don't worry about those boundaries. If you look at all the challenges, there's one overriding theme behind all these challenges. And the thing is, right now, we're horribly inexperienced. There are no experts out there. If somebody says there's an expert, they're lying to you. Do not hire them. There's just a lot of inexperience. So we're still trying to learn a lot about these things. All right, with that out of the way, let's talk about the first challenge. And the first challenge in my mind is, why are you bothering to use microservices? I mean, what's driving you to try to do this? A lot of people say because it's a hot topic. That's not a good reason. You should have some real reasons behind it. So my reason behind sort of doing microservices sort of came out of this sort of model. I call it my requirements uncertainty model. That says there's somewhere between complete uncertainty and certainty about your requirements. And frankly, we were able to use waterfall very effective for building systems when I understood the requirements. The requirements are either well known or at least able to document, they're experts existing. And the nice thing about Agile was when Agile came along, we were able to tolerate, through some good design principles, tolerate some uncertainty associated with the designs. So all of a sudden, Agile fit very nicely into this niche that says, I kind of have an idea of what I want, but I can leave out some of the details till later. I can sort of discover these as I go along. But there was this great unknown process I used to call the graveyard. If you have no idea what you wanted to do, you were kind of be stuck there. You had no chance of success whether using Agile, Waterfall, or anything else. This kind of is my vision back in the year 2000 when I started doing Agile. But I've sort of come to a different opinion that some of this uncertainty stuff I can actually handle. And a lot of this comes from the idea that we're trying to solve a different type of problem today. There's a new type of problem on the horizon I call fuzzy problems. Not the traditional problems of what's your bank balance, some of those other things, but the fuzzy problems. Should I loan you money? Or is this a fraudulent transaction? What book do you want to read next? What Google advertising keywords should I buy? These are fuzzy problems, and they're ones we're starting to attack more and more now. And my favorite model for sort of understanding these comes from a guy named Dave Snowden. Unfortunately, with a name like Dave Snowden, he gets no page one hits anymore. But a very bright Welshman that talks about these things. And he divides the world into these types of problems you're trying to solve. He says simple problems are ones where the cause and effect relationship is very straightforward. If I make this sort of change, it's going to turn the switch, it's going to turn the light on. Turn it off, it's going to go off. Then he says there's complicated problems. This is where you have experts, because there is a cause and effect relationship. It's just it's really complicated and only experienced people can understand it. But Dave Snowden didn't stop there. In fact, the profound thing he says is there are other types of problems, ones he labels complex and chaotic. And a complex problem is where the cause and effect relationship does not exist. Yes, if this happens, I could probably figure out why that happened. But it turns out if this happens again, that's probably not going to be the result. Something else will happen. These are your financial markets. This is Google advertising. These are all the fuzzy problems. And it turns out you have to attack these problems differently. And one of the other things Dave Snowden tells us is that most problems kind of in an unknown state. You don't kind of know what type of problem it is until you try to solve it and sort of watch how it behaves. Is it horribly unpredictable like chaos or complex? Or is it quite predictable like simple? So you have to figure that out. And you tend to have a prejudice of where you want to work in a problem. So if you're a politician, everything is simple. You build a wall between here and Mexico, and all of a sudden all the problems go away. But of course, the problems are complex. It has nothing to do with such a simple solution. But again, people like to think they're simple solutions, so they sell it that way. As for myself, I tend to like complex because there are no rules. I kind of like the idea of no rules. I've been known to try to take complicated problems and make them complex just to have more fun. People usually get rid of me at that time. It's a good idea. So it turns out you organize yourself differently for each of these segments. If you're actually working in a simple problem, this traditional organization structure makes sense. The manager's job is to teach the employees how to do it well. There's a concept of best practice. That's their job. They can measure their success. They can measure how fast you are doing your job. Very successful organization structure. Nothing wrong with that. We get to complicated, though. Complicated problems have experts. And so you got to find these experts. But unfortunately, experts are really expensive. And so you put a team in place to do what the expert tells you to do. And to some degree, this models our software engineering practices of today, where you have a couple of architects and designers who have the experience of doing this, some domain experts perhaps feeding things in. And if you're in an agile world, you use stories, and you feed stories to the programmers, and they measure them, and we count them and see how fast we're working. All makes sense for solving that sort of problem. But when you get to complex problems, when you get to these fuzzy problems, there are no experts. By definition, there are no experts. If someone says they're an expert, they're lying. They don't really know. And if you hire them and to try to solve this complex problem, you'll eventually tire of their bad solutions. You'll fire them, hire another expert. And eventually you'll fire the manager because he must be screwing it up. But the answer is none of these roles work. You can't really do it that way. What you need to do is turn programmers loose, saying, here's the problem we're trying to solve. Here's what success means at a business level. Try things out. Because they're going to work, may work today, may work tomorrow, it may fail the third day. Throw it away, try something else. So the nature of the complex problems. So it turns out that if you go back to that complexity model that I thought in year 2000 was sort of accurate, I now believe that this is fuzzy problems, but they're viable. There are ways to attack these problems. There are ways to sort of solve these fuzzy things. And so typically, though, you look at it from a process perspective, you'll see these sorts of process things associated with solving the traditional problems. And these agile practices make a lot of sense. The idea of stories and they're specialists, we have specialized roles, these sort of things make a lot of sense. But when you're trying to solve a fuzzy problem, these sort of roles make no sense. When you're solving fuzzy problems, it's all about sort of understanding what a feature is. What's the idea? Give me an idea. Don't tell me it's a requirement because you don't know. Give me an idea. Let's try this idea out. We want to use full stack developers because they can solve problems. So I don't want all these specialists because the handoffs are too expensive. It slows me down. I want a system that fails fast. So if I put something out there, it doesn't work, I want to know it's not working so I can stop doing it. So those things are very important to us. Microservices tends to be a technology that solves fuzzy problems very nicely. There are other technologies as well. And you like the concept of event-based architectures. So if you look at it, complex problems and complicated problems, the organization structure should be different. The processes are different. But a lot of times you see us trying to solve these complex problems with our complicated solutions. That's a mistake. So before you go off in microservices, make sure you're trying to solve a problem that needs microservices. If you have a problem that's one of the other edges, don't bother with microservices yet. You're wasting your time. All right, second challenge. How do you get the code out the door? Because really, if the advantage of microservices is to go fast, if I can write a service really quickly and it takes me 6 months to get it deployed, I haven't really bought anything. Why am I bothering again? So how fast does it take to get the code out the door? So being somewhat old, I talk about sort of historic information and going back in history. So here's a chart that sort of goes back to year 1980 and talks about how long does it take to get code out the door. And so I was working for IBM in this time frame, and basically I worked on projects in this time frame that took 3 to 5 years to get out the door. In fact, I worked on a project, it took 3 years to do it. We had 1,000 programmers. We shipped it on time. That was a 3-year schedule. By the way, don't feel sorry for us. We made $1 billion on that software. So it was quite a profitable project. So as time goes by, again, we're getting a little faster. I'm still working at IBM. I'm still working in waterfall processes. But I get my release cycles down to about 6 months or so. Again, this is a logarithmic chart, so anything going down is a really good idea. And then I begin to get myself involved in object-oriented programming, learn about some of the things that Dave Parnas was talking about today, and understanding those better. And it's still getting better, but it's still nice. It's a nice logarithmic curve. And then the bottom fell out. We did something that made us extremely fast in getting delivery out the door. And to some degree, it goes back to how fast I can do that. Now, if I go to companies and say, how fast can I deliver things, I get very interesting stories. I get a story about, if I want to get something out the door, well, here's the process I follow. It's sometimes modeled after trains, saying, here's a train, it comes along periodically. You need to make sure you get on the train. If you miss this train, of course, you got to wait for the next train. And they say, well, this is how it has to work, because we have to have these trains, these periodic deliveries. And I say, well, interesting, what happens when you have a bug? Do you have to wait for the next train to fix the bug? Oh, no. We have another way to fix bugs, because it's got to fix the bug, and it's kind of a little bit of code change, so it's not so much risk. So I use that process. So I say it's really interesting, because you really do microservices, you want to treat everything like they're a bug. You want to treat everything like I can get out really quickly, because it's really small and really safe to deploy. So I'm not going to use your train process, I'm going to use your bug process to get code out the door. When you get really good at this, you can go really fast. So how fast can you go? Well, I was working at a startup in London about 4 or 5 years ago. We did a lot of things around microservices there, among other ideas. And we got to the point where we were basically shipping new code to production every 3.5 minutes. Every 3.5 minutes, we had some new code into production. We were very successful as a company. With 50 employees, we made 50 million pounds that year. Rarefied country. Because we were solving fuzzy problems and we were fast. We were trying ideas out aggressively. So again, got to fix your deployment process. And so to some degree, DevOps and the concept of moving to DevOps and getting your operations house cleaned up, get yourself to the point where you can push code out the door quickly, is a very important first step to going to microservices. All right, then you have a design decision to make, represented by the third challenge. Do you want to build synchronous services or asynchronous services? Synchronous services are the ones that use RESTful interfaces. You sort of call, you get an answer back, or you pass it to control the next guy. You have to know where these guys are, you build around that. Or asynchronous, where the idea these services don't really know about each other so much. There's much less coupling between those. There is a flow, but it's sort of much more hidden. Interesting enough, I had a debate about this with a colleague of mine, Chad Fowler. Chad Fowler has very much the same history I do, other than he's much younger than I do. He was the CTO of 6 Wunderkinder when they got bought by Microsoft. So he and I were on the stage in Dublin talking about microservices, and we said all the things we saw initially. They're small, they're very fast. But his conclusion at the end of his presentation was, you should use synchronous services. Because first of all, that's what you as a programmer have been trained to think of. Here's step 1, here's step 2, here's step 3. Code it that way. The flow with RESTful interfaces is very much like flow of column modules. It's the same architecture. It's not a big deal. You should just use that. I stood up, said all the same things, and said, oh, by the way, you should use asynchronous. Because you're really trying to get the benefit of microservices, you're after fast deployment. You're after lower coupling. You're after these fuzzy problems. And yes, you absolutely have to teach the programmers how to think this way, because this is not the normal decomposition that we've been trained to do in schools and the like. So what do I mean by asynchronous services? Basically, you probably are using some sort of event bus. This is kind of my cartoon model of this. I drew this with my new iPad one day as I was flying across the country, and so this is done with my finger, so I do not apologize for the art. But the first thing in that upper corner is key. We're moving to the concept of event bus for these fuzzy problems. So the idea of an operational SQL database is dead. You're moving to an event bus that's keeping track of things. So if this is my email address and I change it, I don't want to lose that data point. That's a very interesting data point. I want to keep that idea. The transition itself may be interesting. If you go into Silicon Valley and look at the big companies, they're all moving to event buses for the operational database. Yes, they still have a SQL database somewhere for reports because SQL and reports work really well together. But they're moving to that. So the idea of the event bus is something that I'm putting every possible event on. Every possible event. That's why I call it the rapids. It's a fast-moving stream of events. Everything is going on. Not only the services talking to each other, but also the log messages, which are interesting. The traffic stats for your servers, user journeys, put that all into the same event bus. Have that Google capability of gluing these together in different ways. You still have a need at some point for what I call ponds, which are the stagnant representation of entities. They kind of lost the time nature of themselves, but they are good for reporting. So again, you write yourself a little microservice that's sitting there on the rapids, looking for things that should change. Oh, email address changed? Well, let me update my data warehouse. That's another microservice. So when you have that sort of structure, you start with a high-performance bus. The nice thing is, these are not the enterprise service buses that we had 10 years ago. It's a whole new generation of these buses that are very fast and very dumb. Kafka bus is my favorite. It's the one that LinkedIn uses. They open sourced it. It's been in production use for over 10 years. I feel very good about it. It's a persistent bus. It can handle 250,000 messages a second. I have trouble with my applications drowning that bus. I don't work on bigger things. So you sort of build a series of tiers of where you're going to attach your services to this bus. So you build tiers for service points attachments. And when you actually do things, you want your services, though, to sit there and listen to the rapids for something interesting going on, listen to one of these sub-things, and publish it back to the rapids. You don't just publish it back to your channel, because that says only my channel needs this. You're not that smart. You're not planning for the future. You're not thinking about the things that will change. Now, some interesting architectural patterns emerge out of using event buses, things we haven't seen before, things that haven't been documented so well. But things like the need pattern, where you basically have a service right here saying, I have a need. I'm expressing the need on the bus. I don't know if anybody's listening. I don't care. In this case, I got a couple of guys listening. Now, this could be something like, should I loan you money? So I have a little blue service here who's looking at your bank account. It sees regular deposits, feeling good about you. It sees that you never go negative. So it says, yeah, I probably should loan you money. I got another service that's going out to one of the service bureaus, the credit bureaus, and checking your status there. It has a vote. And you could think about other types of people that have other votes in the future. The thing is, the blue service and the green service do not know about each other. In fact, the yellow service doesn't even know anybody out there even exists at all. So it turns out it's very easy to write a new version of the blue service and just put it up there and let it also vote without taking down the first one. Oh, and by the way, if one of the other services, the green guy, goes down, I'm still getting answers. Now, the answers may not be as good, but it's a fuzzy question. I don't know for sure if I loan you money, you'll ever give it back. It's a fuzzy question. So it turns out fuzzy questions are fault tolerant. You take advantage of that, this architecture. So again, these guys vote about what they think the answer is. The guy collects the answers, but draws a conclusion on his own. The need pattern. So again, you can sort of see it in this sort of world. It's easy to build an application and get it out there very quickly. So in this case, we actually built an application like this for one of the hotel chains. We put advertising on their home pages, trying to sell them more. You're coming to a site, you're trying to buy something, I want to sell you more. So who has ideas about what I can sell you? Well, company has. We have a discount on your cars this weekend. Plus, each individual rental location has its own ideas and own problems this weekend. So they'll have their own offers. And they'll compete for the business. And they can be up and running. And then I can make it smarter on the fly. I can add information about your membership in my frequent renter program. I can look at your usage patterns in the past and decide what sort of offers make better sense to you. A smarter application, continuously deployed. Again, with continuous deployment and you get rid of the deployment backlog, you can improve things very quickly and try ideas out very aggressively. All right, so that's the idea of asynchronous versus synchronous. Fourth challenge. As I sort of mentioned, you got to kill the database. The centralized database is killing you. Because you make any change to that, you have to make sure you do lots of other things. A lot of this idea goes back to Fred Brooks, someone that Dave Parnas I know knows really well because he was the chairman of the department at the time. But one of the things that's sort of the philosophy behind that was that if you get the data structures right of your application, the code writes itself. And I kind of grew up in this in IBM. This is the philosophy we developed under. That we would get our data structures, DSEX back in the day, and we'd actually have a programmer whose job it was to maintain this data structure, to make sure it was always understanding what was going on. And then we'd write the code around that, and it all worked really nicely. Well, there's an interesting corollary. So the design idea works really nicely. But there's sort of an interesting corollary to this design problem. And that is, if you decide to change your mind about something, all the code is suspect. All that code is no longer may not be valid. And so we need to test all that code and make sure this change did not impact it. And when we started doing that sort of thing, of course, waterfall is a natural outcome of this. Let's make all the changes we need to, and then we'll test everything, and then we'll ship it. Making small changes is really hard in this environment. Well, this is the 1970s view. Roll it forward till today, even starting back in the 1990s. So instead of a central data structure, we have a database. And we have people whose job it is to maintain the database. And they're the only ones allowed to make changes to it. Sound familiar? And by the way, you get the database right, it's easy to write all the applications around the database. But if you go in there and have to change that database, all the code is suspect. We need to test it all again. So if you have a centralized database, you will fail with microservices because you can't make changes to the database fast. All right, so question is, how many databases should you have? So this is a question I sort of ask clients as they go into them and they talk about microservices. I say, how many databases do you have? I had a conversation with the chief architect of one firm who basically said, well, we have 3 databases, but I'm trying to get it down to 2. He's kind of embarrassed he has 3. And I'm like, gee, no, the right answer is actually 300. 1 for each microservice. It's the last conversation we ever had. He was not ready for that conversation. That's kind of okay. He wasn't going to understand it anyway. So, again, how many databases? The idea is they want to have one big database that has perfect information that's always kept up to date. That's their goal. When you don't realize that, that kills productivity on all the other dimensions. You can't make swift changes safely. So what we like to do is basically have use the event bus as our data of record, because it's a raw data. And each little service will have its own little database that it needs for its information, but only have in that database what it needs. And that allows me to make changes to it quite readily. So sort of going back to this model, for example, that little green service at the top that's sort of sitting between the current application and the event bus, this actually consists of 4 different containers. There's a little service that sits there and puts a message on the bus. There's one that listens for the answers. We're going to take the answers and stick them into a Redis database, a little lightweight thing running in a container. And then we're going to save up these answers and then respond to the web page in 300 milliseconds. That's another piece of code. So I call this one microservice, even though it's 4 containers, because if I change that Redis database structure, I got to retest all this code. It's all tied into that. So as far as I'm concerned, 2 services that share a database are actually one service because of the ability to change it. So you got to tear the database apart. All right, so you're going to tear the database apart. So what's your first inclination? Well, you move into what I now call the entity microservice trap. First thing you want to do is, of course, you take your database and say, well, I need to break this guy up. So I got these major sets of tables in it around these concepts. So, of course, the way to break it up is to break it all in those table boundaries. So let's take each one of those and sort of do that. And by the way, take all this code I have running around there, fine. So how do I break this up? Well, basically, I take these pieces, I make their own little databases, wrap a little service around it called the order service or the customer service. And look, I got microservices. Well, actually, look, you got nothing. Now you're doing joins across RESTful calls. They don't perform very well. And by the way, it's the same application code, still now calling multiple databases to do this work. You've really gained nothing by doing this. You have exactly the same architecture, only you have some new pitfalls. So that's not the way to break it up. One of my first starting points is I tend to break up things along the join tables. Turns out that join tables are more behavior related. So if the idea you sort of take these or tease these apart that way, you say, well, here's a couple of services that are kind of related to each other. So I can write a database around each one of those. And now I write behavior-oriented services around those. So for example, ordering and billing are kind of things associated with these sort of databases. And these are sort of behavior-oriented services. They can be relatively small and understood. And fulfillment and returns can be handled with these sort of databases. And these are used for my reordering my forecasting and other things like that. So the right way to break your database up is along its behavior lines, not around the raw data. So again, a trap you can fall into very quickly. And I see a lot of failures in microservices because they built entities and think they've done something. All right, so number 6. There's an interesting conflict in my mind, and it's mostly partly in my mind, between microservices and functional programming languages like Clojure. And a little of this is because of some reasons of where my background is. I have a heavy object-oriented background. And I think microservices are very much like object-oriented design in terms of how you think about them. Because they're basically very small, they're well-contained, they have a single responsibility. They have encapsulation in that they sort of hide their own little database. So they have a lot of the same concepts around that. And we like to talk about communicating with messages to each other. It's a natural metaphor in objects. It turns out to be a practical metaphor in microservices. So that's how I think about microservices. Well, let's contrast that to how I use functional programming paradigms. Well, one of the things about all these functional programming languages, they love immutable data, data that can't change. It is, if I have an array and add a new element to the array, I have a new array. I don't just have a modified, I have a new array. And they take advantage of this immutability in how they do things to build their pure functions. And so when you start building with these languages, you wind up building yourself a tier of function that you transform data from one form into another through these various transforms. But when you start looking at the intermediate data structures here, you wind up seeing that these data structures are very, very complicated. And they really are tuned for the next phase of the process, the next function to be called. And if you think about it, nobody else wants that data structure. So to make this a little microservice by itself doesn't make a lot of sense. So I've had experience now with 3 different companies using functional programming and microservices. So the first one is a company I worked in London. We had over 300 microservices. This is a company that was going every 3.5 minutes deploying something new. We use lots of different languages. We use Ruby for doing front-end work. We use Node.js for traffic monitoring. We use Clojure for heavy lifting. Heavy calculations were all done in Clojure. And it kind of all worked really well together. So that worked really nicely. Then I worked for the Daily Mail in London. And the Daily Mail, again, the Aldridge online newspaper, we wound up using Clojure and Node as our languages. Clojure for doing the really hard stuff, and Node for monitoring the traffic. Giving reports back to our editors about how good their articles were, who was reading what article. So it wound up, we had 3 Clojure services, not microservices, services. There's 4,000 lines of Clojure there. And by the way, 4,000 lines of Clojure can move the earth. That's a lot of Clojure code. But the other things were microservices. The Node.js was microservices. The average size of those microservices was 18 lines of code. 18. They're small. We had dozens of those running. So again, it made sense, but again, Clojure didn't necessarily fit into the silo of microservices. Then I moved on to work for a California startup where we're doing a lot of very expensive calculations. We're doing supply chain, we're doing customer win-back, we're doing a lot of these really complex applications. We use Clojure as our language of choice. We started out with about 25 services, and then the number started shrinking. Because the question was, well, why am I putting this into a separate service when this function only feeds this function? Let's put them together in the same package. So we did that. So I'm not sure if Clojure is not an alternative way of solving problems to solving problems with microservices. I'm still looking at this because, again, I'm inexperienced here. There's a new hope on the horizon in my mind, and that's this language called Elixir, which is a functional programming language built on the Erlang virtual machines. And it sort of has the promise of having lots and lots and lots of very tiny functions working. Kind of sounds like microservices. Dave Thomas, the guy who wrote the book about Ruby, also writes a book about Elixir. And he's now a big fan of this language for doing these really tiny things. So I'm trying to learn that as well. So functional programming versus microservices. Maybe 2 different choices. All right. So now you decide you want to do microservices and you got your database torn apart. Well, where's my architecture? Where's my frameworks? Well, the sad answer is it's too young for any of those things to exist. Yes, vendors out there who will sell you things. Run away. Run away. They're not ready to talk about these things. If anything, they're going to lock you into a monolithic sort of waterfall thinking strategy, lock you into the tool set. Instead, there's a lot of open source out there that seems to be very successful. You want to actually take open source ideas and play with them. One of the biggest guys in this space, of course, is Netflix. Netflix is a microservice implementation. It is synchronous, not asynchronous. It's synchronous. They basically decided they're going to deploy into the cloud. They went and built lots of frameworks to make this work and open sourced almost all those frameworks. There's over 40 open source frameworks associated with Netflix. And when they were building new big systems in the US, a lot of people are moving this as their stack, including the US Department of Defense is building their new applications on this stack. It's kind of their new architecture for doing the big systems. But if you're really into this stuff and you really like the idea of small microservices, the people who are playing really well in this space is Node.js. They have a philosophy of very, very small services, very, very small libraries. That's very much what we want to be into. So they're very active in this space. You can find lots of open source things to do this. Seneca is one of the frameworks out there that does this from a company in Ireland. Ran across this one just by Googling around it. Uses ZeroMQ, one of my favorite frameworks for these things. So again, no frameworks are out there. So somebody comes along and tries to sell you a Spring Boot, run away. All right, the 8th challenge. We haven't got a design patterns book. The nice thing about the Gang of Four book was that it basically explained, here's some problems and here's how to solve these problems. It gave you the trade-offs and all sorts of things that are really nice and elegant about that. We have not got that book for microservices. There are a lot of books out there, and a lot of very good books about microservices, but none on design patterns. For example, the need pattern I described is not in any book yet that I've ever seen. And yet it's a fundamental pattern for that style of programming. So instead of patterns, you really got to go and look at other companies and see how they're doing it. The nice thing is there are conferences out there that are dedicated to microservices. There's one in particular in Berlin, not that far away from you guys. So once every February, we get together in Berlin and have a conference only about microservices. And you'll see Adrian Cockcroft from Netflix will be there, as will many of the other. Chad Fowler will be there talking about what he did and how he worked. If you want to learn about these things, talk to the people who have done them. The nice thing is there are also meetups. I know there are meetups in these various countries. I know more meetups are starting. But go exchange your stories. If you're doing microservices, please talk about it. Share your knowledge, share your mistakes. All right, challenge number 9, next to the last challenge. If you just do microservices, you will fail. You need to do things associated with other technologies as well. So if you just do microservices without worrying about some of these other things, like for example, going into the cloud, you better be in the cloud. You better be in containers. You better be thinking about full stack developers and DevOps. That better be part of your thinking. You got to reorganize yourself around these concepts. You better be, if you're working on a fuzzy problem, you better be thinking about a managerless process. One hacker away, programmer anarchy, one of these really aggressive agile processes that basically says, let's work on fuzzy problems, let's go really fast, let's try ideas out. So again, you will fail if you just go in there and say, oh, well, let's keep everything else the same, but I'm going to do microservices now. Definitely will fail. My final challenge, which I labeled 10 through N because it's going to be an infinite series of these, and that comes down to what is a microservice. You're going to have a lot of definitions now about microservices. The vendors will try to convince you they know how to do microservices. I noticed that IBM with their WebSphere product, a very, very old product, it says it does microservices now. Why would it ever do that? So watch out for that stuff. So when people say they do microservices, I have kind of 3 types of questions I ask. And it's sort of these 3 sort of metrics. First of all, tell me fundamentally, are you synchronous or asynchronous? What's your philosophy here? Or is it all about RESTful interfaces and calling and back and forth? Or is it more of an asynchronous event bus sort of world? Which world do you live in? Second metric, how many services do you have and how big are they? Oh, we have 3 microservices. They're about 100,000 line of code each, not microservices. And finally, how many databases do you have and how many services? What's that ratio? If you have just 1 or 2 databases and lots of services, you're not in microservice world. So going back to that middle one, if you sort of look at the size of the services and how many services you have, I sort of draw this chart, which is a log-log chart. Get your head around that, log-log chart. So the size of the application in the bottom, number of services here. And we kind of have what I call the Rails and Java zone. It's one big application, lots of lines of code. Then you have the SOA world, which was a refinement of that. Basically said, let's take our giant thing and turn it into smaller pieces, still along the lines of 50 to 100,000 lines of code. And then once sort of virtual machines and then containers came along, a lot of us discovered microservices. And I say discover because basically the fundamental reasons for microservices appeared, many of us at the same time. New problems to solve, new technology to work with. So this is what I call the microservices zone. This is where you need to be living to be a microservice. And so if that's my monolith world, and I will never do monoliths again because my life is too short. I do an animation on this, how this works. It goes there. This is where the company in London was and made all the money. 50 employees, 50 million pounds. That's where they lived. That's Netflix. 1,000 line of code services, 1,000 lines of Java code. One programmer understands it, can write it, maintain it. So if you're not in the green zone, I don't consider you to be a microservice. So that's kind of my last challenge associated with that. And so I would say be very careful with microservices. In fact, the most important thing is make sure you really need them, and then make sure you can actually handle them when you get them written. Make sure you can deploy them aggressively and understand them. And that's my 10 challenges associated with microservices. And I think we still have a little time for questions. Oh, actually, questions are coming in through a third-party trick, right? And do we have any?
A second. You ask questions to a chatbot. I mean, I've been following the questions, but yeah, like since we are moving up, like I'll just pass the mic for now. But please do use the bot.
Yeah, you mentioned you do not believe IBM doing microservices. It's because IBM has a new product called WebSphere Liberty, and now it's Open Liberty, and it does microservices beautifully. Actually, I have a talk after lunch, just a demo how Open Liberty can do the microservices. Yeah.
Yes, I know you work at IBM London. I worked for IBM for 17 years myself. We should talk afterwards. I don't believe it. So you and I will disagree. Other questions?
Hi, Fred. Thank you for the great presentation and for visiting Belgrade. I wanted to ask, you said that basically the fuzzy problems are the ones which are a good fit for the microservices. And in your presentation, I saw that you were involved in implementing microservices with Daily Mail. Would you say that Daily Mail is kind of a traditional business? In a way, it's publishing articles. How is your experience with that? How does that fit in?
It turned out most environments have both fuzzy and traditional problems in them. Certainly publishing the newspaper is a traditional problem. And that's what we use our closure programming for. But we use the little microservice, the Node.js services, we're used to do traffic monitoring, looking at what article is coming out, is it being popular as it should be. In other words, we're feeding back information to the editors to help them make decisions about a fuzzy thing. Because they don't know this is the right title, they don't know it's the right picture. That's the fuzzy part of that problem. And that's where we apply the microservices. Again, if you told me I was solving a complicated problem, I would probably use microservices, but I've been doing this a long time. But I would say if you're doing a startup and you want to do a traditional problem to be solved, I would not say start out with microservices.
Hi. Thank you for this presentation. I wanted to ask you, you mentioned that the proper microservice size would be like 1,000 lines, for example.
That's the biggest I'd ever have is 1,000.
Yeah, the biggest. And every microservice should have its own separate database. So if we have like something that requires more code, how could we split the database without replication or something like that? So it's a bit like clashing these two conditions.
But there's two observations. First of all, when solving a fuzzy problem, you can live with eventual data consistency. You don't need to have perfect consistency at the time for solving a fuzzy problem. For example, the fact that you just rented a car, you're now a platinum user. I can wait till tomorrow to give you a platinum offer because I don't know if you're going to take it anyway. It's fuzzy. Now, if I was trying to do something like your bank balance, I cannot be fuzzy about that. And I would not choose to use microservices for that. But a fuzzy problem will allow you to do eventual data consistency. And so I take advantage of that. So I don't mind working with day-old data sometimes in these services. So I do replicate lots of data. In fact, generally, I have a little ETL process that'll pull things out of the data warehouse every night to refresh the databases of my services.
Great. Hello? Yeah. Sorry. Another thing regarding that, this replication, you use like cron jobs, for example, every day, or you have something like publishing mechanism on Kafka where the replication is done automatically everywhere in every service, which has its own part of database or replica.
Again, we're all very inexperienced in this. My favorite technique is going to use cron jobs because they're fine, because I can live with data that's a day old for these applications. If it's something that needed something more rapidly updated, I would probably use my event bus.
Okay, I'm using event bus. Thank you very much.
And that concludes it.
Right,
So
very
thank you.
Thank you.